In this section, we will learn how to find the equation of plane if 3 points which belong to that plane are given. Obtained equation will be in its general form, which, of course, as we have already seen, can easily be transformed to any other form. We begin with 3 points T1, T2 and T3, which are not on the same line. For that 3 points, there exists one and only one plane pi, which contains them. We want to determine its equation in general form: ax plus by plus cz plus d equals 0, where a, b, c and d are known numbers. Arbitrary point t will lie in that plane if and only if its coordinates xt, yt and zt satisfies that equation. Glance at the pictures reveals relations we are looking for. Let t with coordinates x, y and z be arbitrary point in the plane pi, different from t1, t2 and t3. Because points t, t1, t2 and t3 lie in the same plane, vectors determined by that points, means vectors t1t, t1t2, t1t3 are coplanar, as we can see on construction graph. As we have already learned, triple product of coplanar vectors must equals 0. That means vector t1t dot product with cross product of vectors t1t2 and t1t3 must equal 0. Now we express that vectors in the standard base. That's also something we already should know how to do. Just take difference between corresponding coordinates. For example, vector t1t equals x minus x1 multiplied by I plus y minus y1 multiplied by j plus z minus z1 multiplied by k. Same for other vectors. One more thing that we should already know is that triple product of that vectors can be represented as determinant of the following matrix. In the first row, we place coordinates of the first vector. In the second row, the coordinates of second vector, etc. Equaling determinant of this matrix with 0, we get this equation. In first row, x minus x1, y minus y1, z minus z1, etc. equals 0. To summarize, this is the equation of the plane if coordinates of the 3 points t1, t2 and t3, which are not on the same line, are known. Obtained equation doesn't look as an equation in general form, but in any particular case, when point coordinates are given, expansion of determinant on the left side of equation leads us to equation of the plane pi in general form, as we can see in the following example. Example 1.11. Find the equation of a plane passing through points t1 with coordinates 2, 4, 1, t2 with coordinates 1, 2, minus 1/2, t3 with coordinates 2, 1, minus 1/2. Solution. Requested equation of plane we obtain simply by incorporating coordinates of the given points in the equation above. Putting coordinates of given points into this equation, we get following equation: x minus 2, y minus 4, z minus 1, etc. equals 0. Simplifying, we get x minus 2, y minus 4, z minus 1. In the second row, minus 1, minus 2, minus 3 over 2, etc. equals 0. Now, expanding determinant from the left gives this equation. Simply multiplying by minus 2 over 3, we finally get equation in general form. X plus y minus 2z minus 4 equals 0, which is the equation we are looking for.